Hi gents, welcome back to the next part of the 2014 question 2 paper. Not paper, sorry, just question 2 from 2014. It's relative velocity. And we're just on to this little B part here. It says, totally different question to the one above. At noon, ship B is 300 kilometers south of ship A. So it might be worth here just doing a very rough diagram. So it's ship B is south of ship A. So we'll put B here and we'll put A up there, and we know that there's 300 kilometers between them. Okay, ship A is traveling southwest. So it is going south and west like that. So if we just have a little look at that idea there, it's directly southwest, okay, just to say, and it's going at 24 root 2. So if it's going directly, we know that that's 45, so we can actually break it down into its I and J components. 24 root 2 is the hypotenuse, just to be clear. Okay, that's what we're told it is doing overall. So we know that that's X, and actually this is X as well, because we're dealing with an isosceles triangle. So there'll be a few ways to do this. You can use Pythagoras' theorem to get it. You can say that the sine of 45 is equal to the opposite x over the hypotenuse 24 root 2, and you will then have that x is equal to 24 root 2 sine 45. So x in that case will turn out to be 24. There will be another way of doing it as well. You know the root 2 triangle where this is 45 degrees, you know, where both have to be the same. You should, off by heart, know the 1, 1 root 2 triangle. Well, if you just scale it up a bit, and this is 24 root 2, so it's 24 times bigger, then this other side is going to be 24, and that will be 24 times bigger. So of course it's going to be that. But there would be loads of ways to do it. Pythagoras would also work if you wanted to. What's the important part here? What is the ship doing? So A is doing, now remember it's going left, so it's minus 24I, and it's going down, so it's minus 24Js. So we've resolved the vector if you want to think of it like that. Okay, so that's what we have. I'm just gonna get rid of this thing here. Okay, what now? What are we told? Ship A is traveling like that. Ship B is traveling due west. So it's just going west. Simple as that. Not much to that. So there's no J component here. So it's just a very strict minus 31 I's. Okay, because it's going left. So far, so simple. Part 1, I won't say like that the whole way. The part 2 here looks like it's going to be tricky enough. So part 1, find the magnitude and direction of the velocity of B relative to A. Okay, so B relative to A. So we'll take B and we will subtract A from it. Okay, B is minus 31 I's, and we're going to take away A, so it's going to be minus 24, so it's plus 24 I's, and it's going to be minus a minus 24J, so it's plus 24J. Okay, so this is minus 7I plus 24J. That is what it's going to be doing. It asked us for the magnitude of that, so no problem. Well used to getting the magnitude now. It's the square root of minus 7 squared plus 24 squared. I'll just grab a calculator for that. So 24 squared is that, plus 49 is 6250. Oh, it's actually a nice number. Yeah, not one I had stored in my brain. So we get the square root of 625, and the root of 625 is of course 25. So that's the magnitude. It's just 25. And it also asks us to get the direction of it. So let's think about this. what's it doing? It's moving over 7 and it's moving up 24. So, I don't know, something like this. Okay. Moving over 7, moving up 24. Okay, don't put in, well, I mean, no point putting in -7. So we're going to get, what is this angle here? We'll call it alpha, sure. Keep it Greek. What are we dealing with? We're dealing with the opposite and the adjacent. So tan of alpha is equal to opposite 24 over adjacent 7. Alpha is tan inverse of that number there. Okay. I'll type that into my calculator. 24 over 7. This equals alpha is equal to 73.739, so we'll just call it 74 degrees there. Okay, phone's off in class, of course. Let me just get that. Okay. That's what we have. We have the velocity and we now have the direction. I don't know, should we say it's like west 73.74 degrees north? I guess we can say that. Say that there. Okay, that is what, so if we actually just draw that in here, that is velocity of B relative to A. So if A is staying the same, that is what it appears to be doing, and we know that this is 73.74. Okay, let's come back up here because there's some important bits here. If the ships can exchange signals for 2.8 hours, find the value of D. That is when they're within a certain time of each other. Okay, so let's just continue that line on here. Okay, so this is what that's doing. This is B relative to A, as we had there. Okay, so first of all, we'll draw the line which is at right angles. Now, they have to be within a certain distance of each other in order to be able to exchange signals. So for instance, things we can say. It's not going to be that distance for sure, because if it was that distance, it would immediately be out of range the second that it went anywhere in that direction, or indeed before it reached that moment, it would still be out of range. And we're told that it's in range for 2.8 hours. Okay, so if it is in range for 2.8 hours, I might just make a different color on it. Oh, that's bad. We know that that range is going to be like, we'll just say that it's there, and it's going to be in range for 2.8 hours. So this distance here is longer than the other one, so it makes sense that that would be the case rather than just the shortest possible distance. And it's going to be obviously symmetrical out there. See if I can actually draw something with some symmetry. That's about as good as I can do. Okay, so this bit here, that bit there, has to be 2.8 hours. Okay, that whole thing there, 2.8 hours is what that whole thing represents alongside that distance there. But what we're interested in is D. This is the longest distance when they can exchange signals. So it says A and B can exchange signals when they are within that. So that's like the upper limit. So we are trying to get what that thing is there. Okay, let's zoom in to this thing here. First thing that we'll do is, oh God, I'm gonna hit Control Z on that to try and get it back. Excuse me. Okay, sorry. Did not mean to get rid of that thing there. First thing that we will do is we will maybe give some names to this. We'll call this thing, let's say, sorry, P, Q, and OR. P, Q, and OR. Right, we will try to get AQ. Okay, we're going to get AQ. We'll get that distance going the whole way along, which is the shortest distance. Sorry for making a muck of this. as I go along. Okay, what can we say here? Make this a little bit bigger so that we can see it. What we can say here is this, is that AQ, it's part of a big right angle triangle where we know a couple of things. We know that the hypotenuse is 300, and we also know that this angle in here is going to be 90 minus 73.74. So if we do 90 minus that, we know that this is 16.26 degrees. Okay, so remember this thing that we want, that bit is the opposite, and 300 is the hypotenuse. Opposite and hypotenuse, we're dealing with sine. So the sine of 16.26, sine of that is equal to the opposite, which is the thing that we want, that's AQ, over the hypotenuse, which is 300. So AQ, the thing that we want, is equal to 300 sine 16.26. Okay, so AQ is equal to, so we can get sine of that number, which is a nice number, and multiplied by 300, and it is 84. Okay, so it's 84 is, I'm going to get rid of that bit there. 84 is that length from there to there. We know that that is there. Okay, remember D is the thing that we want. So I'm going to put D in here in black, and D is the thing that we want. So now, can we figure out some more things? Well, we can use a little bit of Pythagoras' theorem here, I can see. We know that it was going to be 2.8 hours from there to there. That's the whole time that they're in range. So just by symmetry, because this is going to be half that distance, we know that this bit here is 1.4 hours. Okay. We also know what it's doing. It's doing, was it 25? Is that what we got? Yeah, we know that it's doing 25 kilometers every hour. So it's 25 and it's going for 1.4. It's 2.8 the whole way, but we'll just do it to 1.4 so that we're only getting that little bit in there that I'm squiggling along there. So 25 times 1.4 comes out to be 35. So now what do we have? We've got a right angle triangle. You can see it there. I'll just upright it. We know that that's 84. We know that that's 35. D is the thing that we're after. It's just Pythagoras. 84 squared plus 35 squared is equal to D squared. Okay, let's do that. 84 squared plus 35 squared is equal to 8281, and that's D squared. So D, the distance, is the square root of that number there, and it is a nice number. So D is 91 kilometers. They can talk when they are in a range of 91 kilometers. And yeah, we have answered the question. That is what they wanted to get. Okay, their shortest, the shortest approach them, because that could have been a question that they asked as well. The shortest approach was 84. That's the time when A and B are closest to each other, but the time when they can swap signals is 91 kilometers. Okay, gents, that's a great question, a lovely one to start off with. I think in terms of leaving cert. So really take your time with that one, try it out. Hopefully you already did try it out. If you weren't able to get it, have a go at it now. Okay, you've seen the video, you know what the answers are. That's always helpful. But honestly, there is a lot to be gained even when you know what the answer is, just from doing it out, just so your mind is getting used to it. Certainly, if you're just looking at the video and that's it, it is less helpful than you actually trying it. Okay, gents, I will actually maybe stick up an assignment. I'll do it as an assignment. Get you to do a leaving cert question. You can take a photo of it and send it on to me, and we'll do it like that. Okay, gents, thanks a million. Take care.